All right, let's do some related rates problems here. Now in this video, we're going to do a few examples, but we're mainly going to focus on related rates examples of geometric figures. And we'll do some other types in later videos. All right, so in this example, we have a rectangular swimming pool that is 10 foot wide by 20 foot long and has a uniform depth, which means there's no shallow end and no deep end. It's just the same depth throughout. And this pool is being filled with water. All right, so here's our pool. It's being filled with water. It's 20 feet long by 10 feet wide. And if T is the elapsed time, so we're timing how long it takes us to fill this pool up, H is the height of the water, and V is the volume of the water, we need to find an equation that relates V to H. That's the first thing we want to do. So we want to find an equation that relates the volume of the water in the pool to the height of the water, or another way to say that is the depth of the water. Well, because the pool is rectangular and it's a solid depth from one end to the other, we know a formula that relates the length, the width, and the height or the depth of a rectangular shaped object. And that's the volume of the object. The volume is length times width times height or depth. And we already know the length and the width of the pool. So we have the volume is equal to 20 feet times 10 feet times the depth or the height. And 20 times 10 is 200. So that means in this specific instance, a formula that relates the volume to the height of the water or the depth of the water is V equals 200 times H. So what that means is if we want to find the volume of water in the swimming pool at any given time, we can plug in a depth of the water, whether it be 1 foot deep, 2 feet deep, 3 feet deep, and then we multiply that depth by 200, and that gets us the volume of the water in the swimming pool. The second part of this is that we want to find an equation relating dV over dt to dH over dt. Okay, so what does that mean? Well, dV over dt is, of course, the derivative of V with respect to t, which is time. So dV over dt tells us how the volume is changing at any given time. And dH over dt tells us the instantaneous rate of change of the depth of the swimming pool at any given time. And we notice that the volume and the height are both being differentiated with respect to time. So to find dV over dt, we would differentiate the volume, or V, with respect to t. And to find dH over dt, we would differentiate the height, or the depth of the pool, with respect to t. And the good news is that we've already found a formula that shows the relationship between the volume and the height of the water, or the depth of the water. It's V equals 200 H. So now we just differentiate that equation with respect to time. But because we're differentiating with respect to t, and our variables are V and H, we will have to use implicit differentiation to do this. Differentiating the left side of the equation, V, with respect to time, gives us dV over dt. And differentiating the right side of the equation, 200H, with respect to time, gives us 200 times dH over dt. And that is our equation relating how the volume changes with respect to time to how the height or depth of the pool changes with respect to time. Now let's use that information to help us solve some problems. This question asks, at what rate is the volume of the water increasing? All right, let's stop right there. Anytime I'm working these types of problems and I see the word rate, I immediately start thinking derivative. So this says, at what rate is the volume of the water increasing? that is asking us to find dV over dt, because dV over dt is the rate at which the volume of the water is changing over time. But if you want me to use this equation to find dV over dt, then you have to give me dH over dt. So let's keep reading. The second part of this question says, if the water level is rising at 0.025 feet per minute. So they've given us another rate here, because rising at 0.25 feet per minute, that's a rate. Well, what rate is that? That's the depth rate, or how the depth is changing, or how the height of the water is changing with respect to time. So they have given us dH over dt. So dH over dt is 0.25 feet per minute. So the rate at which the volume is changing with respect to time, or dV over dt, is equal to 200 times 0.25. So at the exact instant that the water level is rising 0.25 feet per minute, the volume is increasing by 50. Now what is that? 50 what? Well, our units here are feet and minutes, or feet per minute. And because dV over dt, that's a volume, volume is always calculated in cubic units. So this would be 50 feet cubed per minute. At what rate is the water level rising if the pool is filled at a rate of 10 cubic feet per minute? And I see the word rate again in this question, so I know we're going to use our rate formula. dV over dt equals 200 times dH over dt. Now what are we given? We know that the pool is filled at a rate of 10 cubic feet per minute. So is that rate dV over dt, or is that dH over dt? Well, the dead giveaway is that the units are in cubic feet per minute. So that means that this is dV over dt. And that is the rate at which the volume is changing over time. So substituting in 10 for dV over dt gives us 10 equals 200 times dH over dt. And we want to know at what rate is the water level rising. Well, that would be the change in the height of the water, or the change in the depth of the water. So we want to solve this equation for dH over dt, because that is the rate at which the water level is rising. So divide both sides by 200. That gives us 1/20th. And again, because our units are in feet and minutes, that is 1/20th of a foot per minute. And that is the rate at which the water level is rising, or dH over dt.